A very good afternoon, students. Today we'll start our lecture 14 on irrigation scheduling. In last class we studied few efficiencies, but today we study with the irrigation scheduling. What is irrigation scheduling? It is defined as frequency with which water is applied based on the need of a crop and nature of the soil. It answers the question when to irrigate, how to irrigate, how much to irrigate. So that we call it as irrigation scheduling. It is nothing but number of irrigation and frequency required to meet the crop water requirement is called as irrigation scheduling. It can be defined as it is a scientific management technique of allocating the irrigation water based on the individual crop water requirement under different soil and climatic conditions with an aim to achieve maximum crop production per unit of water applied over a unit area and unit time. We call it as irrigation scheduling. That is, when to irrigate, how much to irrigate, and how much frequency we have to irrigate in order to meet the crop water requirement is dealt under the irrigation scheduling. So, irrigation scheduling is a decision-making process repeated many a times in a year involve when to irrigate and how much to irrigate. So, irrigation efficiency in India is 30 to 70%. So, it's such a low irrigation efficiency in India. So, either due to application or faulty application practices, the efficiency is very low. And time of irrigation is very important to get the maximum water use efficiency. So, to answer all these problems, irrigation scheduling or scientific irrigation scheduling gives the real-time answer. So, there is three criteria of irrigation scheduling, or we also call it as approaches in irrigation scheduling. Which are those approaches? The first is soil moisture regime approach. The second is climatological approach. And the third is plant index approach. These are the three approaches of irrigation scheduling. The first approach is soil water regime approach. In that we have first is feel and appearance method. The next is depletion of available soil moisture, and third is soil moisture tension or soil moisture suction. We call it as these three method comes under the soil moisture regime approach. The next is the climatological approach. The climatological, as it indicates, the climatic data. Which are the climatic data required for the irrigation? Either evapotranspiration or potential evapotranspiration. So that is answered by the cumulative pan evaporometer reading, and we have the second approach, that is irrigation water divided by the cumulative pan evaporometer ratio that gives under the climatological approach. Then third important approach, that is the plant index approach. The first in the plant index approach is the visual symptoms. The second is soil cum sand mini plot technique. The third is plant population. The fourth is growth rate, and the fifth is relative water content. The sixth is canopy temperature, and the seventh is canopy temperature. Eighth is indicator plant, and the ninth is critical growth stages. So we will deal each one in a detailed manner, which is very important for the exam point of view. The first is soil moisture regime approach. That is, in that we have feel and appearance method is the first approach. The feel and appearance method. You take the soil sample, you feel it. If it is dry, you can feel that there is no moisture in the soil, you go and irrigate. It is a crude or a farmer friendly approach of soil moisture irrigation. It is based on the visual observation, and feel by the hand gives you the feel and appearance method. The next in that we have another approach, that is depletion of available soil moisture. How much percentage of moisture has been depleted from the soil? That gives you a real-time understanding of when to irrigate. So this is the first approach, that is feel and appearance approach. If the moisture content is between 0 to 25%, 25 to 50%, 50 to 75%, 75 to 100%, and at field capacity we need not to irrigate. So under that condition, various coarse soil, light soil, medium soil, heavy soil, what appearance you give or what things you feel, based on that you go for irrigation. But generally in soil sense we will use a technique ribbon formation. When the soil has a high moisture content, when you press slightly with the hand, there is a formation of a ribbon. So they need not to irrigate. When there is a breakage of the ribbon formation, you need to irrigate. If you see here a good example of coarse texture soil. At 0 to 25% moisture, very dry, loose, single grain. Whereas 25 to 50% moisture, where appear to be dry and will be ball, will not form a ball with pressure. Then 50 to 75%, you find a little ball formation, and 75 to 100% tend to stick together, slightly sometimes forms a very weak ball under the pressure. So the next is depletion of available soil moisture. Generally, at 20 to 25% depletion of available soil moisture in the soil is found to be optimum from the moisture sensitive stages. That means when the soil has 100% moisture content, need not to irrigate. If its soil has 50% moisture content, it is a sorghum crop. So under the 50% soil moisture condition, if there is a sorghum crop, you need to go for irrigation. So based on the depletion of available soil moisture, you can go for the irrigation. The next is soil moisture tension approach. What is soil moisture tension? Tension refers to the tenacity with which water is held in the soil particle. And for that measurement, we have learned in lecture 4 class, we use certain instruments such as tensiometer, gypsum block, Newton moisture meter. So to measure the soil moisture tension, easily we can use the tensiometer. It works up to a range of 0.85 bar. So the tensiometer will give you the reading. So whenever critical soil moisture tension is reached 0.4 to 0.6 or 0.7 bar, it is the upper tensiometer, then irrigation is commenced. So this, if you consider this as the tensiometer, if there is a full moisture content, saturated condition, there is no depletion, there is zero saturation or 0 bar is the tension. But when it is a dry condition, it is close to 0.6 or 0.7 bar, which is an indication that you need to go for irrigation. The next, these are the some threshold values for the scheduling of irrigation. If this is a centibar, or if you can mention it in a bar, it is 0.3 to 0.6 bar. For sugarcane, you have to irrigate at 0.3 bar or 30 centibar. Maize around 25 to 50 centibar. Cotton, these are the tensiometer values, tensiometer readings where you have to irrigate the tensiometer. The cotton, it is 40 bar. Sorghum around 50 bar. Tobacco 30 bar. Soybean, the tobacco at very low moisture itself, it is a moisture sensitive. So you have to irrigate even at a tension of 30 bar. Soybean 50 to 60 bar. In wheat around 40 to 50 bar. And the depth of maximum root intensity, most of the crop is 30 centimeter. The next, the second approach is the climatological approach. Here, a function of evaporative demand and the atmosphere under adequate soil water condition will be taken into consideration. Thus, this method, the water loss expressed in terms of either potential evapotranspiration or cumulative pan evaporation value will be used for scheduling of irrigation. So let us discuss what is potential evapotranspiration. The potential evapotranspiration, as we have discussed, it was given by Penman. It is a concept, it is defined as amount of water transpired in unit time by a short green crop of uniform height completely covering the ground and never short of water. How, from where we will measure the potential of a land where green crop, a grass is completely grown. This soil is never short of water with a good water, and evapotranspiration measured under such condition we consider it as a potential evapotranspiration. And to measure that we use USWB class A open pan evaporometer. So this is the USWB class A open pan evaporometer. See, in exam point of view, they will ask you the diameter kind of thing. See, the diameter of this circle is around 120.7 centimeter. This is called a stirring well. It has a scale and it is covered with a mesh and it is placed on a wooden stand above 15 centimeter height, and the water level is in the rim of 5 to 7.5 centimeter. and the height of this cylinder USW class A open panometer is 25 centimeter. So this is the USWB open class A open pan evaporator. The pan have a higher rate of evaporation than a larger water surface. So we use a term called as a coefficient. 0.7 is generally used as a correction factor, converting the observed pan rate on a large water areas. So you have to multiply with a factor 0.7. So in order to give a real-time error, overcoming the error on a larger area. So that it is made from the 20 gauge galvanized iron sheet. 20 gauge galvanized iron sheet. So the next we have sunken screen pan evaporator. The two types of pan evaporator. One is class A open pan evaporator and second is sunken screen open pan evaporator, which was given by Sharma and Dastane. It was given by Sharma and Dastane in the year 1968. Developed the sunken screen open pan evaporator, which is there in IRI, New Delhi. The evaporator consisting of a evaporation pan, a stirring well. It has a evaporation pan. It has a stirring well. Stirring well and a connecting tubes. So what is the open pan diameter? It is 60 centimeter and it is at a depth of 45 centimeter, which is made with a 20 gauge galvanized iron. The evaporator is installed by digging a pit in a suitable size, placing the pan and backfilling the earth with a due compaction. So this is how we use another instrument to calculate the pan evaporator for irrigation scheduling. This is under the climatological approach. Yes, the next under climatological approach, there is a second approach called as IW by CPE ratio method of irrigation scheduling. What is IW by CPE ratio? The ratio between the depth of the irrigation water and cumulative pan evaporator from USWB class A open pan evaporator. A pan evaporator minus the precipitation since the previous irrigation will give you a data for calculating through IW by CPE ratio. IW by CP ratio 1, what it indicates? It is equal to the water has to be irrigated, that is equal to lost in the evaporation. The amount of water which is lost in the evaporation is equal to amount of water that has to be irrigated to your field. So 1 indicates irrigating the crop is equal to the lost in the evaporation. You have to irrigate equally to that of lost in the evaporation. So few IW by CP ratios are there. For an example, crops such as groundnut, barley, pearl millet, you have to irrigate at the IW by CP ratio of 0.6. That is irrigation water divided by cumulative pan evaporator ratio is 0.6. Then wheat, maize, sunflower, it is 0.9. So the rice has I because the water requirement is high. Rice and potato it is 1.2. Safflower it is 0.4. Rapeseed and mustard it is 0.7, cotton it is 0.75 and sugarcane and sorghum it is 0.8. Then after the climatological approach, the third approach of irrigation scheduling is plant indice approach. So generally plant used as an indicator for showing the water scarcity in the soil. Based on that you go for irrigation. One good example here is the first method is visual plant symptoms. So plant under the water stress condition shows certain symptoms such as wilting, drooping, curling, rolling. So these all indicate that you have to irrigate the plant. This is the one approach where farmer can easily accept this and you go for irrigation. So the next approach is the soil cam sand mini plot technique. This comes under the plant indice approach. In this we use sunflower crop as an indicator. Sunflower crop which is used as a soil moisture scarcity indicator. Where the principle involved in this technique is to reduce artificially the available water holding capacity of the soil. An area, what we have to do, how we will do, you have to take an area of select 1 by 1 meter plot and take a pit, remove the pit. So followed by a 5% sand. 5% sand of volume is added to the dugout pit. Then the pit is filled with the mixture while filling up every 15 centimeter well compacted so that soil in the pit retains the original bulk density. Then crop is sown normally. Which crop? Sunflower crop. You have to sow normally. So as when the plant in the mini plot shows wilting symptoms, then it is a warning sign that you have to irrigate your main field. So this plot shows early wilting then compared to your main plot, where you can go for irrigation scheduling. The next is plant population approach. As the plant population increases, competition increases. So select an area where you increase the plant population, where wilting symptoms seen early than in your main plot, that is an indication or a sign for an irrigation scheduling. The next, the relative water content. This is another approach of soil moisture scheduling. So relative water content can be calculated by fresh weight minus dry weight divided by turgid weight minus dry weight multiplied with by 100 gives you the relative water content. So based on this formula you can calculate the plant water status, and based on that you can go with the irrigation. Whenever the plant exhibits these values, irrigation can be scheduled. However, the main drawback is it is tedious approach. And who gave this concept? It was given by Wetherly in the year 1950, where actual water content in the leaf or plant sample will be used for the irrigation scheduling. However, this approach is highly tedious, so farmers generally don't follow this approach of soil moisture irrigation scheduling. Then plant water potential. The moisture content in the soil can also be used as a indicator. However, the moisture content in the plant and the tension in the plant can also be used as an indication of water scarcity, and based on which you can go for irrigation. Here, the method measures the energy status of the water. It measures the energy status of the plant water analogs to the tension of the film water in the soil. So, the better index of physiological and biochemical phenomena occurring in the plant and plant leaf water potential can be precisely measured either by a pressure bomb or pressure chamber apparatus. So, a specialized device is used for the plant water potential measurement. We call it as pressure chamber apparatus or pressure bomb apparatus, which determines the soil plant water status or tension. While sunflower, we see here sunflower, they have 1.2, 1.4 megapascal at vegetative pollination and seed formation stage. So you have to bring to that condition. So if the conditions are very low than that, you have to go for irrigation. So this is an plant water potential approach. So the next is canopy temperature approach. The difference in canopy temperature minus air temperature will also be used as an indicator for soil moisture irrigation scheduling. Several studies show that plant temperature or canopy temperature are adequately reflects the internal water balance of the plant. So use a potential indicator for the scheduling. It can be measured by instruments such as porometer or infrared thermometer. Porometer or infrared thermometer, it is used to measure the canopy temperature. It is used to measure the canopy temperature. For maize, it shows that canopy temperature rises to more than 0.7 degree over the ambient temperature from 1:30 to 2 p.m. 2 p.m. of hour. Irrigation need to be scheduled accordingly. So the canopy temperature, we also call it as canopy temperature difference. So how it can be calculated? Well, the difference between air temperature minus the canopy temperature will give you the indication of soil moisture status or the moisture status in the plant. Based on that, you can go for irrigation scheduling. Then next we have indicator plants. Few indicator plants can also be used as a irrigation scheduling. One good example is sunflower. Apart from that, we have amaranthus, oat, maize and Niger. The next, the ninth approach of irrigation scheduling is the critical growth stage approach. So each plant has certain critical stages for irrigation scheduling. So that critical stage you have to irrigate. If you don't irrigate at that critical stage, your yield will reduce more than 90%. So such stage we have been identified. So based on that, one can go for irrigation. So which are those stages? For rice, it is tillering, heading and flowering. For sorghum, booting, blooming, milky stage and dove stage. For ragi, it is primordial initiation and flowering stage. Maize, dazzling, silking and pollination stage. Bajra, heading and flowering. Wheat, this stage is very important, the crown root initiation stage. Then shooting stage and growth stage. The next is groundnut, it is flowering, peg penetration, pod development. Sesamum, flowering and maturity. Sunflower, star formation, flowering and seed development. Safflower, rosette, flowering and seed development. Soybean, flowering and seed development. Cotton, it is flowering and bud development. Sugarcane, formative stage and stem elongation stage. Tobacco, rapid growth and topping stage. Chili, flowering and fruit development. Potato, tuber initiation and tuber maturity. And onion, it is bulb enlargement and ripening stage. Yes. So today we have studied on the irrigation scheduling of the crop. If you have any doubts, please comment in the comment section. Thanks for hearing.